Hello guys, welcome to LeetCode, and in today's video we will discuss LeetCode question 2359 that says find closest node to given two nodes. So here you are given a directed graph of n nodes numbering from 0 to n minus 1 where each node has at most one outgoing edge. So it is a directed graph and we are given and nodes are numbering from 0 to n minus 1 and each node has one outgoing edge, at most one outgoing edge. Okay. Now further, a graph is represented by given 0 index in edges. So here we are given one edges array where the edges of I represent an outgoing edge from I to its value. Means that is for edge from I to the value of edges of I. Got it? So we are only given the edges that are outgoing and not the incoming. So these are only the outgoing edges. Further, we are given two nodes, node 1 and node 2, and we need to return index of a node that can be reached from both the node 1 and node 2, in such way that maximum distance between the node 1 to the node and node 2 to that node is minimized. Okay, so you are given two nodes, node 1 and node 2. You need to find one common node such that the distance from node 1 and that common node as well as the distance of node 2 and that common node is minimized. Or you can say in other words such that you need to find a common node that is at minimum distance from node 1 and node 2. So this is in simple terms. And if there are multiple answers, then we return the node with smallest index. Okay, and if there is no possible answer, then return -1. So yeah, now we will look at this example for better understanding. So this is the edges array and total number of nodes are 0 to 4. Sorry, 0 to 3. There are 4 nodes. So what does 2 represent? 2 represent that index 0, that is the node 0, has a directed edge from 0 to 2, as you can see here. Similarly, directed edge from 1 to 2, 2 to 3, and -1. That means there is no edge, outgoing edge from the node 3. And here we have two nodes, node 1 and node 2, that are 0 and 1. So yeah, as you can see here, the most common node, the most closest node that is common to 1 and 0 is 2. See here it is at distance 1 and here it is also at distance 1. So the common node that is closest to 0 and 1 is 2. So we return 2 here. Got it? You can also say that 3 is also one common node, but it is further from 2, and that's why we didn't consider 3 as our answer. So now let's take a look at this example. Here we have two nodes, 0 and 2 we are given. See, a common node between 0 and 2 is 2, only 2, because see, if you are thinking of 1, then 1 cannot be said as a common node between 1 and 2, because there is no edge from 2 to 1. So 1 cannot be a common node. So the only common node that is remaining is 2. That's why we written 2 as our answer. And also regarding the distance from 0 to 2 is 2, and to 2 itself is 0. Okay, so I hope you guys have understood somewhat what is the meaning of this common node and all. Now let's take a look at one or more example for better understanding. So if this is the case where this is the graph and this is also one graph, okay, and you are given two nodes 1 and 0. So here there are no common nodes between 1 and 0. So here we will simply return -1. Got it? Okay, now if you have something like this, here node 1 is this, node 2 is 4, and you need to find a common node. So here the common node between 1 and 4 is 3. So we will return 3 here. And there is also the closest common node, right? In this case only, if you have something like this, like 3 to 4, then the common node would change to 4, because that is the only common node between 1 and 4. So that's how depending on the direction of the edges our answer will change. And if you have multiple common nodes, we will return the nodes with the smallest index, as the question says. Okay, so now to derive an intuition, see, two things to note here is you need to find the minimum distance between node 1 and that node that is common node, and node 2 to that node. So since you need to find the distance, what you have to do, you have to do some types of traversal, that is either BFS or DFS, right? Secondly, you need to check the distance from both the node, from node 1 as well as node 2. So you need to do what? Twice, two times traversal, okay? And after performing two times traversal, we need to pick a node that is of minimum distance and common, and it is common to both. We need to pick common minimum distance node. That's what the question is asking. The question is asking to find the node that is common to both node 1 and node 2, and it is at a minimum distance, right? So yeah, keeping these three things in mind, we will approach this question. Okay, so now let me trace out for one of the example. Let me draw one graph here. 0, 1, 2, 3, 4. We will take 5 here. 6, 7, and 8. Okay, so in the first trace, in the first trace, that is BFS or DFS, you can say any traversal, we will start from node 1. Let's say 0 is a node 1 and 8 is a node 2, and we will do traversal and find the distance. So here if I am writing, so here this value will represent the distance, and similarly we will find the distance with the second traversal by taking the node 2. Okay, so yeah, now let's begin. If you have to traverse from 0 to 1, 0 to 0 distance is 0, 0 to 1 distance is 1, 0 to 2 distance 2, 0 to 3 distance 3, 0 to 4 distance 4, 0 to 5 distance 5, 0 to 6, no, it is not possible. So we will store something like max. 0 to 7, not possible, max. 0 to 8, not possible, max. Similarly, from 8 to 0, not possible, so max. 8 to 1, also not possible, not possible, not possible, not possible. So for 5, it's 1, 2, 3. Here it's 2, here it's 1, and here it's 0. Now we will check for both the distance. So as you can see here, it is max, it is here, it is max. So the only node that we found that is common here is 5. So this is how we will take the node that is common. See, other nodes have at least one of the value max. So if you try to compare the distance, then this will only be the answer on the basis of distance. And also if there were more common nodes, let's say if there was a situation like this, like 9 and 10, the 9 and 10 would be also a common node for node 1 and node 2. But the thing is, here the distance would increase. So in whatever be the case, our answer would be 5, the node at the index 5. So this is how what we will do. We will traverse the graph. We will from the node 1 as well as node 2. We will store the distances, then check for the distances and return our answer. So guys, I hope you understood the approach as well as the intuition. So now let's move on to coding part and here. Okay. So let me first take n, that is total number of nodes here, and that is equal to edges dot size. Let me take one adjacency matrix for convenience. Vector int adjacency matrix of size n. Now we will store the edges in this adjacency matrix. Auto e of edges. And since this is a directed graph, we will store only from the source to the destination, therefore the edge. So adjacent of I dot push back edges of I, and this is also the case only when edges of I is not equal to -1. That means there is an edge. In only that case we will push that. Okay, now next thing what we have to do, we have to store the distances of both for BFS1 and BFS2. So let's take something like hash map int of let's say distance 1 and distance 2. See, if you don't want to take a hash map, you can also do something like vector of size, and you can do this because the nodes are only from 0 to n. So yeah, you can do this also. Then let me take two queues, q1 and q2. Let me take one visited, add v1 and v2, both of size and let me initialize all the values as false. Similarly for v2. Okay, now time for BFS 1. So for the BFS 1, what we would do, we would first push the node 1. We would mark it as visited, that is v1 of node 1 equal to true, and we will start traversing, that is until while q not q1 dot empty. We would take the current node and from the q1 and we would pop it. Also before this, what we have to do, we have to make distance 1 of node 1 equal to 0. Yeah, because from the basis of the node 1 we will be checking for distance of other nodes. Yeah, correct. Okay, now we will update the distance of other node that are adjacent to this node. So for auto neighbor of this current node, if not visited of neighbor, since we haven't visited this neighbor node, then in that case what we would do, we would first update the distance of this neighbor to distance of current plus 1. Yeah, and the next thing is we would push that into the queue. Got it. And also we would mark v1 of neighbor as true, that means we have visited. Okay, now same thing we would do for BFS2, that is traversing from the node 2. So it would be in the Q2. So let me change these things first. It would be Q2 everywhere. Here would be V2, that is the second visited area. Here would be this 2. Here it would be this one, distance 1, distance 2. Here it would be 2, and here it would be 2 as well. Okay, so now what we did do BFS traversal, each one from node 1 and one from node 2. We have stored our answer in this disk. Now we will check for the distance. So let me take one int max list equals to int max, and let me take answer as -1. Okay, so yeah, now we will traverse this unordered map, and you can traverse anyone like these one or these two, that is for the BFS1 or BFS2. Int element here is it dot first. Okay, now if this 2 dot find element is not equal to this 2 dot end, that means that is one common element that we have traversed in and stored in distance 1, and also that element is present in distance 2. For that element we would check for max this distance from node 1 to node. So let me take it in current equal to maximum of this 1 of element comma this 2 of element. Okay, and if this current distance, let me name it current distance, is less than the maximum distance. Okay, so in that case what we would do, we would update maximum distance to current distance, and we would update our answer to that element. Okay, now if there is one case where current distance equals to maximum distance, so in that case we would and answer is greater than element. So here in this case we need to update our answer, because the question says if there are multiple answers, return the node with the smallest index. So here we need to update our answer and store element with the smallest index, and in the end what we would simply return answer variable that we have here. Okay, so I hope you guys understood this. Here the question says maximum between the distance from node 1 to the node and from node 2 to the node is minimized. So here we are taking maximum of this distance from node 1 and node 2, because this one stores all the distance from node 1 and these two stores all the distance from node 2 to that node, to that element. It is common. And if it is less than maximum distance, then we would simply update our answer. So yeah, now let us try to run this. Okay, the test cases are passed. Let us try to submit this. Okay, yeah, so our code got accepted. So I hope you guys understood the approach, that why we are doing two BFS traversal here and how we are finding a common element. So that's all for this video. Yeah, and talking about the time complexity, the BFS traversal will take big O of n times because we are traversing all the n nodes, all the possible n nodes, and also we are storing the n nodes. So so the space complexity would be also big O of n, whether it is a visited array or unordered map. The space complexity would be big O of n. So yeah, both the time and space complexity would be the same, that is big O of n. So yeah, that's all for this video. I hope you guys understood the intuition as well as approach and how we will code it. But if you have still any doubts, then let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.